Good afternoon, everyone. Can you hear me? Hello. Hope I'm audible. My screen is visible. Yeah. Okay. Let me unmute everyone. Yeah. Just give me a minute. Yes. So far, we have only 41. Shall we wait for 2 more minutes? The strength is.
Yeah, we can wait for 1 minute and get started, madam.
Can anyone confirm whether you're first semester batch student or second semester?
Second semester, madam. This is first
Okay,
semester
I
complete.
hope completed. Super. So
Yeah.
I hope you're all aware of Taxila portal, right?
Yes, ma'am. Yeah.
Yeah, so no issue. Like I don't want to explain the course administration and all, right? So
Yeah.
thank you. Yeah.
Yes, madam. And also yesterday we received a mail from you regarding the schedule for quiz and assignments as well.
Yes. Yesterday I have posted one announcement regarding it's a tentative schedule. Most probably it's the final schedule. There is a possibility. So in order to align with the live session, there will be a change, but I'm not sure. That's a final day schedule. Okay, quiz and assignment.
Yeah, fine, madam. If at all
Yeah.
if there is anything, we can discuss that.
Yes, sure. Okay, let me start my session. Very good afternoon to everyone. Myself, Indumati Prabhakaran. I'm your lead instructor and instructor in charge for this course, Artificial and Computational Intelligence, right? I hope my screen is visible, right?
Yes, madam.
Yeah, thank you. Right. So as per today's plan, okay, before going to start, I just wanted to introduce myself. I have been associated with the BITS WLP division since 2021 as a guest faculty. And my research specialization and interested area is like machine learning, deep learning, and medical image processing. I have taught like different AI/ML courses, ACI, machine learning, and deep learning courses, right? So moving forward, this is sorry. If you don't have any queries, please mute yourself. Yeah. So moving forward, as per today's plan, I just wanted to give you the uh, introduction, that is course administration, as well as the formal definitions of what is AI and what are all the applications of AI. Are you able to see my annotation?
Yes, ma'am.
Again, let me reshare it again. Yes. Just a minute. Yeah. So the first point is like course administration. We will talk about course administration, and we will proceed with the formal definitions of AI and what are all the applications associated with each and every domain. And then I'll give you one. I'll take one sample, simple toy example to disseminate the entire course overview. Right. So that is what my today's plan. Yes. So moving on to the course outline, I hope you're all aware it's a 5 credit elective course. Yes. Are you aware of it? It's a 5 credit, it's not elective. I'm not sure. It's a 5 credit course, right? Designed to provide you with a fundamental and foundational understanding of how intelligent system works. Okay. So here we will be looking at intelligent system from 3 main perspectives. The very first thing is we will focus on the design of intelligence agent and understanding how they are built and structured. That is what our first concern. And the second thing is we will move into the algorithmic perspective to get hands-on with the strategies and processes these agent follows, right? And the third perspective, the finally, we will study a computation and optimization to understand how we make these agents work efficiently. These are all the 3 main perspectives which are covered in this course, right? So first point is a solid foundation for designing intelligent agent. The second one is represents the knowledge. Okay, see, whatever I have, explained as of now, everything is technical jargon for you, right? Don't worry. I'll take one simple traveler salesman problem and I'll introduce all the terminologies associated with this course for the entire context session 16 so that it will be easy for you to understand and you can easily connect the dots and you can easily incorporate whenever I have explained the topics in detail. Okay. And with respect to the courses, our focus, the main objective and the main focus is about the principle of artificial intelligence and concepts, algorithms involved in building rational agent, right? And these are the topics will be covered in the modules, like in the upcoming modules, informed, uninformed search and applications, logical, probabilistic knowledge representation, as well as the reasoning and application, right? So these all are the modules or topics which we are going to cover in this course. And what are all the topics you cannot expect, right? Topics which are not covered in this particular course is what not to expect, right? That is advanced AI topics. This course doesn't cover any advanced areas like computer vision, deep learning, or artificial neural networks, right? And as well as the hardware aspect of the design, hardware part. We will focus on the software and algorithmic aspect, not on the hardware needed to run AI system. So this is what our the introduction and about the course. Uh, Moving on to the course pedagogy, weekly we will be having a live session, 16 contact session, and most probably we will arrange 4 dedicated webinars and lab implementation for you. And then moving on to the EC1 components, right? Evaluation component is like EC1, EC2, and EC3. EC1 weightage is 30%, 30 mark. EC2 is again 30%, and EC3 is 40%, right? EC2 and EC3 both are written exam. For EC2, you'll be having open, it's an open book, sorry, it's a closed book examination, right? EC3 is EC3 is an open book exam. Final exam is open book and it's closed book. And moving on to the EC1, we will deploy 2 assignments. One is pre-mid semester and one is post-mid semester, right? There will be 2 assignments assignment 1 and assignment 2 with weightage of 13% and I think it's 15% and 10%, right? And similarly, 5% weightage assigned for awarded for quiz, but there will be 2 quizzes. You can attend both or you can attend either any one of the quizzes because best of 2 will be considered, right? It's not average. Okay, 30% for mid semester and 40% for end semester examination. Is this clear? And in the Taxila portal, I'll share the announcement as well as the tentative schedule, even the reminders regarding your quiz as well as assignment submission, assignment rollout, everything will be posted in your announcement section. You can get it from there. And if you have any academic related queries or assignment related queries, quiz related queries, not support, all academic related queries or concern can be escalated in the discussion forum in Taxila portal, right? Just create a discussion thread and write your concern there and within 48 hours, your query will be resolved. Okay. Is this okay? Regarding the course administration?
Yes, madam.
So, right. Let me start with one toy problem here, right? It's a traveler's problem, traveler's salesman problem. What is your understanding about TSP?
Yeah, trying to recall, madam, like a traveler need to go from source to destination city. So the
Okay.
puzzle will be like helping him to find the optimistic route to go.
Okay, fine. Fine. So the shortest route or based on your objective, we should find out the optimal solution. That is the objective here, right? Just assume, right? I'll explain the scenario. Sorry, I'll explain this example with multiple scenario, right? According to your first design or first scenario, right? Uh, it's not a normal car. Just assume it's a self-driving car or self-autonomous car or the agent is sitting in the driver's seat, right? This would be your source and this is your destination, right? From this source point, the agent needs to pick up the customer and it should drop the customer in the destination point. This is the objective or simple scenario, right? Yes. Just try to correlate or just try to connect. What suppose as a human, if you are new to this locality, what is locality here? The entire map can be considered as my location. Yes?
Yes, ma'am.
Yeah. So the entire map can be considered as my location. If you are new to this particular location, as a human, what you will do? How do you search or how do you proceed?
Google Maps.
Google Maps.
Yeah, Google Maps.
No, you don't have soft. So I mean, any smartphones with you or no internet at all.
Checking with
You
the
will
people
check with other
nearby.
people.
Checking with the neighbors and you will, it's
I mean,
simple,
small goals, ma'am. Small, short goals.
short routes. Okay. If you have
Short
multiple.
goals.
Okay. Anyway,
Like
from this source to destination, you'll be having multiple route. Yes,
Yes, madam.
there is a possibility. There is a possibility. As a human, what we will do if nothing is known well in advance or earlier, so as a human, we will start exploring. Yes,
Exactly, ma'am. Yeah.
it's exploration. I'm just introducing the terminologies, right? So if nothing is available, what is our scenario? If there is no information at all. What is information here? In your memory as a human, in our memory, if nothing is stored, right? Then we will start exploration. How do you connect here? Exploration is fine. What about this scenario? How do you connect with this Asian scenario?
moving somewhere and learning again and then moving forward.
None of the informations have been stored into the agent memory. Yes?
Yes, ma'am.
Yes. No information or no map is located No map is stored into the agent knowledge base, right? So usually we call it as database. Here it is a, hereafter we are going to call it as knowledge base, right?
Knowledge
I'm,
base.
yeah, I'm just introducing the terminology. Okay, in real time scenario, we will call this as we will call it as map or location. With respect to our course, the entire thing will be considered as environment. Yes,
Yes.
yes, I'm just introducing. The first terminology is entire locality or map can be. See, the environment will differ from one problem statement to another problem statement, right? So for this, the map is environment. So the map is environment. And the second thing is knowledge base. What suppose if your knowledge base is empty in the initial stage? That is, nothing is available in my memory, then the agent will start explore the things. Is this clear? Is the flow is clear? Okay, fine.
Yeah.
Exploration, right. Now, actually the first terminology is agent. First one is agent. What is agent? What would be considered as intelligent agent? Or what is artificial intelligence first?
Mimicking human intelligence to the machine.
Super. So if mission, if it could be anything, it could be a mission or
Yeah.
software or agent, whatever, right? So what suppose if it mimics, if it has the capability to mimic the thought process or human behavior, right? It's simple. If it has the ability to mimics the human behavior, then such kind of systems are called as, or intelligence are called as artificial intelligent agent, intelligent agent. Can we say that? Yes. So
Yes,
the next
madam.
thing is, okay, the next concern here is, okay, if you are standing here, how do you know whether this is a road or garden area?
By observing.
By observing the locality. How do you,
Yeah,
that is what,
locality.
how we will know that?
By training, right, ma'am. For example, as how when we say
Based
like,
on the
okay, this is the road
pattern,
we
ma'am.
can go.
Based on the
Based-
pattern.
No, it's very simple. By seeing itself, we can come to know that, okay, it's a road, it's a garden, or it's a platform, right?
Correct.
Yes, ma'am.
Very simple, right? Just try to connect with a simple analogy so that it will be easy for you to connect with this complex terminology. Okay. Yes. So if you are new to this locality, by seeing the locality itself, okay, there is a bridge or there is a road or there is a platform or there is a shop, there is a temple or there is a whatever, right? By seeing, using some sense organs, we can sense the information. That is what connected here, right? So from the environment, we should get the input. Yes, we should get the input. Now I'm just connecting the same thing with respect to the AI scenario, right? How the agent will get to know about the environment? Any idea?
By training, madam. As
Historical data.
Historical
okay.
data. Do you have parallel machine learning course?
actually complete in first semester. Ma'am. That's
Completed
it.
in the
Oh,
first
you have completed first semester. Okay, fine.
Yeah.
See, that is what the very first, that is why I have specifically mentioned your scenario is nothing is available in my
Okay,
memory. No
Hmm.
map
Oh,
at all, no
sorry.
information
Yeah,
at
yeah.
all,
Mm.
no historical data.
Okay, ma'am. Yeah.
So for that purpose,
Hmm.
to perceive the input information, perception, perceive. Yes, another terminology is perceive. Perceive from environment. What is perception from environment, which can be called as input, right?
Yes,
Yes,
madam.
from the
Yeah.
environment, you are trying to get some information that can be considered as an input information. How do you perceive? That is what my question. For human, we have some sensor organs, sensing organs, right? Likewise, here we have some hardware, which is nothing but sensors. Yes, with the help of sensor, just assume in the car itself, there are some inbuilt sensors are available, right? With the help of sensor, the agent can sense the environment. Sensing is nothing but perceiving input information from the, that is perceiving means it will try to get the input information, what is available in the environment that can be perceived with the help of sensor. Is this clear? I
Yes,
have
madam.
introduced 5 terminologies: agent, environment, knowledge base, exploration, perceive, that is perception, percept actually, right? Percept, and then sensor, right? With the help of sensor, the agent can sense some informations, right, from the environment. So with the help of sensed information only, the agent will come to know about, the agent can take any suitable action. What is that?
Moving.
I'll take here.
Okay.
Yes. Start
Moving
location
on.
is this one. This would be your destination, right? From here, with the help of sensor, the agent come to know about, okay, using some sensors, okay, this would be my road. Yes, this would be my road. If the agent observed this information, the agent can proceed with driving. Yes, that is move forward. Actions or actuators. Technically, we call it as actuators. Actuators are nothing but possible actions the agent can perform in the environment. What are all the possible action for this scenario?
Driving or moving forward.
Driving,
Route,
taking
route
turns.
identification.
Yeah,
You
steer
can-
left,
Yes.
steer right, or apply brake, move forward. Likewise, we can
Take a
have
turn.
possible actions, right? Yes.
Yeah.
By keep on move forwarding with respect to this route, the agent will reach to this location, junction J1. Yes. What is your agent initial state? I'm just introducing another terminology, initial state,
At rest.
which is nothing but age. Yes. Agent is located at 8. From 8, by performing some possible actions A1, the agent will reach the resultant state, which is called as J1, junction 1, right? What is this? This is technically called as transition function. Transit from here to here, the agent transit from 8 to 1. Yes. How do you transit? By performing action A1. It could be a sequence of move forward or combinations of move left, right, or whatever, right? It depends. It depends on the situation and depends on the path or route. Okay. So this is technically called as transition function. Transition function. Okay, fine. As of now, till J1 you have explored, right?
Yes, madam.
Till J1 you have explored. Now you just let me know, right? So in this case, for actuator, for simplicity, I'll restrict only with 4 possible action. Move up, move down, move right, move left. Just assume, right? Yes. As of now, how many informations you know? See, initially in your knowledge base is empty. Yes.
Yeah.
Still, I mean, once you have reached this junction J1, kindly let me know. Still, can I claim that my knowledge base is empty?
No.
No, ma'am.
ma'am.
Something
We
we got.
already-
No.
Yeah.
Yeah. What are all the information you know, right? Yeah, just let me know. What is that?
The how travel has happened from 8 to J1
Yeah.
routing.
Yes. Just assume from here, instead of taking this route, I'll connect the direction. I'll connect these 2 cities using a single straight line. Okay, move up, right? Direction is move up. From source 8, if the agent performs move up direction, then I can reach to the junction J1. This is one known information after exploration. This known information is technically called as fact. So this fact should be stored into the knowledge base once you have explored, once you have started to explore. Okay, this is the only information as of now I know. Yes or no? From 8, if I perform move up direction, then the agent can transit to from 8 to 1. That's all. Yes. Shall I proceed? Yeah.
Yes, madam. You're correct.
Yeah. Now your agent start location is 8. The current location of agent is
J1.
J1.
J1, right? Okay. From J1, how many possible actions, how many possible transitions are applicable?
J1 to J2, J1 to
J2.
J5.
Yeah, J1 to J2 and J1 to J5. There are
J5.
two possibilities, right? Like move right, move left, J1 to move left. If you are performing move left direction, then your resultant state is junction 2. From junction 1, if the agent performs move right direction, then your resultant state is junction, it's not junction, it's a dead end 5. Yes, because from 5, we don't have any other routes. Yes. So even, okay, if you have two choices from J1, what you will do?
See which is better and then.
No. Now, that is what
As
the
we
scenario
don't have
we don't
says.
history,
You
we
don't
will
know
follow.
anything.
Yeah.
Sorry?
Okay.
As we don't have history, we will do trial and error. Like we will
Yeah.
go and we will explore
Random
and we will come
selection.
back.
If you have
Yeah.
two choices, you can randomly select, right? The 10th
Yes.
terminology would be randomization. Random selection. Okay. Okay, fine. So, do we need to update this information? Like, okay, randomly, what suppose if the agent randomly selects this direction from J1, move right direction, then the agent will reach dead end. Yes, this should be considered as a fact, right? Once you have reached this dead end, you can come to know about, okay, from here, we don't have any other possible routes to move forward. So what you will do? This should be stored as a fact in your knowledge base. Yes.
Yes, ma'am.
Exactly, ma'am.
Move
Yeah.
right, then you will reach the dead end. This should be considered as another fact, another known information. Yes. Once you have reached the dead end, as a human, what we will do?
Come
Whether
back.
we will stand there or
Come back.
go back. That is
Yes.
technically called as backtracking. Yes, the agent will start backtracking from 5 to 1. Now you have only one choice because from J1 to move left direction, or you can consider it's not actually left, some direction. Okay. So this direction will be considered here from J1 to move left. Then it will be the resultant state will be junction 2. Again, this will be considered as my fact 3. Yes. Okay. See, if you are a customer sitting here, right? What suppose if the driver chooses the wrong route and I mean wasted some 10 to 15 minutes of time to this particular route, and then if the driver come back to the same junction J1, what you will do? What is your reaction? Honestly, tell me.
Angry, getting irritated.
You
Yeah,
get
that's
irritated, you will scold the
Guiding
driver,
the
you will
agent.
give ratings like only two star or 3-star. Yes,
Yes, madam.
Yes,
I'm
ma'am.
sure, right? Again, I'm introducing two more terminology based on feedback analysis, right? Based on feedback analysis, this right can be assessed with the help of or this particular transition, right? Even though you have two choices, randomly, initially I have randomly selected this choice. For this particular choice, I'll get penalty. Yes or no?
Yes, madam.
It's a
Yes, ma'am.
feedback,
Yeah.
right? It's a
Yeah.
feedback system. From the customer, the agent will get penalty for this action taken, right? Same way, what suppose if the agent reaches the destination in a shortest way or in a shortest time or likewise something. Obviously, the agent will get reward,
Reward.
tips or some ratings like 5-star rating like that, right? That is technically called as reward. So each and every transition, right? Each and every transition, or you can say that each and every action can be assessed based on the feedback system, the feedback can be, one is it could be a penalty or it could be a
Reward.
reward. Based on the penalty and reward, the agent will take, more appropriate decision in the upcoming rides. Yes, see, once you have explored this route, whether for the same destination, source destination pair, whether the agent will take the direction, move right direction from junction 1 in the next ride? Will you
It will
take?
not.
No way, no way,
No, ma'am.
because we know that, okay, from here, if I take right direction, it will lead me to reach dead end. I should not take that. So that is what, once you have gathered the information, once all such, exploration, once the exploration is done, you have sufficient amount of information in your memory or in the knowledge base so that you can make, after exploration, you can exploit the solution. That is what our concern. Okay. Is this clear up to this?
Yes, madam.
Okay, so after randomization, you will select the right direction and it is dead end, and apply the backtracking technique. Again, go back from J1 to J2, from J2. Again, still you have two choices, move up, or from J2 you have move left
J2.
direction, right? For move up direction, the resultant state will be junction 3. Here it is junction 4. Likewise, the agent will start explore all possible routes. Yes, all transition needs to be stored in a knowledge base for a future reference, because which transition is the promising one for my source and destination pair, or which one is not suitable. Likewise, you have to explore and you can interpret, you can infer something, right, based on the information stored into the knowledge base. Okay. Yes. So this is about, okay. This is about, we are talking about ride 1, right? This is ride 1. After performing 10 rides for the same locality, for the same source and pair, source and destination pair, what is your conclusion? You have completed 10 rides for the same locality, and that too for same source destination pair. You can conclude what?
Best route.
We'll get a clear picture. No, no. What's
Not
the
best route, not best route. You can come to know about, okay, from 8, I have 2 routes to reach 7. One is 8 to 1, 1 to 2, 2 to 3, 3 to 7. And another, this is path 1. And another route or path is 8 to 1, 1 to 2, 2 to 4, 4 to 3, 3 to 7. These 2 are the only possible routes from 8, to reach 7 from 8. Is this clear? After completion of, it's very simple, simple locality, right? After completion of 10 ride itself, even 5 ride itself, you will explore all possible routes and you can come up with one conclusion. These 2 are the possible solutions, right? All possible routes needs to be stored into your knowledge base. Okay, fine. We have a solution. That is perfect. What about ride 11? For ride 11 also, if the customer or if the agent gets the same source pair, source destination pair, whether your agent will start to explore or what it will do?
Will take
It
from
will use
knowledge.
the knowledge base.
Yeah, it will simply go and check the knowledge base. Do we have any possible routes for same source destination pair? That is 8 to 7. Yes, of course. We have, the agent already observed 2 possible routes, P1 and P2, which has been already stored into the knowledge base. Right. That is, exploration is done, right? Exploration up to this, after 10 rides, your exploration is over. Yes. Now you have 2 possible solutions. How do I know which one is the best one? Even though you have 2 routes or multiple routes, not only 2, right? You can have multiple solutions, but the thing is, out of these 2 solutions, it's agent responsibility, or it's, as a human, it's our responsibility to come up with the optimal solution. Yes or no?
Yes.
Yeah. How do I know whether P1 is optimal or P2 is optimal?
By comparing few
There is
parameters
certain
like distance, time.
and distance.
taken.
Sorry.
Time taken.
I'm not getting,
Comparing
Time to
P1,
reach
P2 by
destination.
distance
one by
and
one,
time.
one by one. Oh, comparing distance and time. Okay, super. Then
Number of obstacles we faced in the route or like
number
that.
of obstacles. Okay. Okay. I'll introduce one more terminology. So far, what are all the terminologies we have discussed so far? Agent, environment, knowledge base, exploration, percept, sensor, actuators, initial state. What is your goal state?
Um,
What is your goal state here?
Fact.
7.
Seven.
Yeah,
Which
7.
mission?
Initial status S8 and
Eight.
goal status
Eight.
node 7. Fact is
7.
nothing but known information, right? And transition function or successor function. We can call it as transition function or successor function. And then back randomization, backtracking, right? Exploration, I mean optimal, this finding best solution, finding the optimal solution is technically called as exploitation. Okay, finding the best solution among the given possible, all possible solution is called as exploitation. Fine. Yes, I have one question here, right? From the problem statement, if you are able to extract initial state, yes, and possible actions, then what would be your next immediate step?
Transitions and storing into knowledge base.
Sorry. Louder, please.
Transitions.
Yeah,
and storing.
perfect. Yes. See, if you know, that is what it's very important parameters from. See, if you have one problem statement in your hand as a AI analyst, you have to check, you have to extract these information initially. Is it, I mean, is there an initial state is available or possible actions are provided explicitly or the goal state or pathcast? Okay, we will discuss the pathcast and utility value later. Okay, if you know for sure about initial state and if you know for sure about all possible actions the agent can perform, simply you can proceed with, you can generate the successor or you can perform the transition. Successor transition, both are same. Yes.
Yes, ma'am.
Transition function or successor function, right? I'll tell you how to proceed this generations like successor function or transition function. Okay. Up to this clear, right? Shall I proceed? Thumbs up. No?
Yes, ma'am.
Yeah.
Ma'am.
Right. Okay, fine. This is about exploitation. Super. Okay. Moving on to the next discussion. Everything is fine. Now, how do I know which route is best route? See, in order to assess the goodness of path 1 compared to path 2, we need some numerical value. Yes. That
Exactly.
numerical value can be technically called as utility value. Yes, this is called as utility value. 15th or 14th fact is utility value. Utility value can be extracted based on the performance measure. How good this path is, how good this particular P2 is. How do I know? Based on some distance, you can consider performance measure can be, can you list out the performance measure for this scenario?
Time taken.
Kilometers, time.
Performance can be, I can assess path 1 and path 2 based on the distance taken for P1 and P2 or time taken to reach for P1 and P2, cost associated with P1 and P2, number of tolls. There is a possibility, right? Number of tolls or number of traffic signals, road quality. Anything else? Anything else? Road quality, time, distance, cost. I can also consider fuel efficiency.
Traffic.
Number of stops.
Number of
Stops.
stops. Stops.
Traffic signal, something, but
It's a cab,
Traffic.
right? Traffic, that is what? Number of traffic signal. If no more traffic signals, then obviously the waiting time is more.
Yeah.
Yeah, that is the
Yeah.
analogy. Yeah. So, okay, I'll restrict. Okay, fine. Up to this, right? So these all are the performance measure for this scenario. Likewise, for another scenario, you can list out some performance measure, right? What suppose if I ask you to consider only one performance, that is distance, then what is your objective function here? What is your objective? We need
Find the shortest.
shortest
Shortest
distance.
minimization.
Shortest.
Objective
Yeah.
can be minimization objective or maximization objective. If your performance measure is distance, we need a shortest distance. Hence, it is comes under minimization objective. This is objective function, 15th point, right? And if you are considered time, minimization. For cost, again,
Minimization.
minimization. Number of tolls, we expect minimum number of tolls. And for traffic signal also, road
Minimum.
quality,
Maximum, madam.
yeah,
Maximization.
fuel efficiency,
Maximization.
Max.
maximization. Okay, I'll give you one more point here, right? In order to assess the path 1 and path 2, what you can do, you can consider only one performance measure, or you can linearly combine multiple performance measure. It depends. It depends on the problem statement. It depends on the analysis, right? It depends on the domain as well. Okay. Okay. There are three possibilities. One possibility is you can linearly combine. You can consider a single performance measure. You can combine a multiple performance measure. Single performance measure, and you can combine multiple performance measure. This is technically called as single objective problem. We will call it as single objective problem. Then what about this one? Multi-objective. And that too, we can consider these into two scenarios. One is, what suppose if I ask you to consider distance plus cost? What is this? Distance is also minimization and cost is also minimization. We can simply linearly combine these two. It's very simple. We can call it as multiple objective function, right? But it's not multi-objective function because both are only one, minimization alone. Yes? Yes. You can use multiple performance measure, but it is not comes under multi-objective scenario. What suppose, since, instead of cost, along with the distance, if I ask you to consider road quality or fuel efficiency, your distance should be minimized, road quality should be maximized. This kind of scenario is called as multi-objective problem statement. Got it?
Yes, ma'am. So same type are there. We can treat that as single object
Yeah,
only. Only
yeah,
different object is there.
Yeah, there are three scenarios actually. One is only one objective. Either it could be minimal or maximum. It's a single objective problem statement. You can also consider multiple parameters, multiple performance measure. And in the first scenario, both can be comes under minimization. It's not multi-object. We cannot say that it's a multi-objective function. But in if you have more than one performance measure, and that too one is minimization and another is maximization, hence it is called as multi-objective scenario. That's all, right? So this utility value is nothing but in order to assess the goodness of one state, one particular transition, we need some numerical value. That numerical value is technically called as utility value. We can extract, how can you achieve this utility value? How do I get it? Using the performance measure, you can get the utility value. Is this clear? The performance measure is again See, all three are simply called as path cost. Right? I mean, it's not like that. Okay, I'll take one more scenario here so that it will be easy for you to understand. I'll introduce one more assessment or evaluation metric, which is called as heuristic value. Okay. I think we crossed more than 15, 15, 16, 17. Yes. 17. 17th point is heuristic value. The difference between path cost or the utility value and heuristic value is, just assume you have, the agent is located in one particular city, from city one, generalized point. Okay, city one. From the city one, the agent needs to reach city three. There are multiple routes, right? From C1, the agent can have three directions. The agent can take three different directions, like J1, J2, J3. Junction 1, junction 2, junction 3. But what is this? Technically, how do you call it as? The agent is located in C1. From C1, if the agent takes move up direction from here, J1, J2, J3. Yes. What is this? From
C1
C1, move right direction. Move
Yeah.
right. Then your resultant state is successor is
J1.
J1. This is one transition, right? These all are the three possible actions the agent can perform from C1. This is move down. Then your resultant state is J2. Move up. The resultant state is J3. Fine. From J1, there could be some possible routes. From J2, there could be some possible routes. From J3, there could be some possible routes, right? But which route I should expand further? How do I know?
First time by exploring and getting the info to the knowledge base.
By
Randomize.
calculating this utility value,
Yes,
considering this.
you're correct. You're correct. That is what. See, you're in exploration while doing the exploration itself. I mean, it's possible to get the distance from 8 to 1, right? After reaching J1. Yes. We can come to know about the distance between 8 to 1 after performing. Move right direction or up direction. Yes. Right. So, yeah. See, here you'll be having some distance. You know about the distance between C1 to J1. Just assume if the distance is 25 kilometers. From C1 to J2, after completion of exploration, it is come to our notice that, okay, from C1 to J2, the distance is like 10 kilometers. Yes, from C1 to J3, the distance is like 20 kilometers. Okay, what is your choice? Even though you have three choices, and based on the performance measure, this performance measure or utility value can be called as a path cost. For this transition, how much path cost is calculated? The calculated path cost is distance, which is nothing but 25 kilometer for J1, 20 kilometer for 10 kilometer for J2, and 20 kilometer for J3. Now, what is your decision? Which junction would you like to expand further?
J2, madam.
J2. Okay. Okay, fine. Just assume from J2, you'll be having two routes, J4 and J5. Yes. And the distance from J2 to J4 is 100 kilometer and J2 to J5 is 25 kilometers. Will you expand J4 or J5?
J5, madam.
Why? What is the,
Um,
do we need to consider this cost alone?
Previous plus this together will
cumulative.
take it.
Cumulative,
Yeah, cumulative.
cumulative path cost. So 10 plus 25, which is nothing but 35 kilometer. Is this clear? Yeah. From here, 10 plus 100, it's 110 kilometer. Okay. Is this clear up to this? Now, I have one more question here, and I'll use black color. From J4, there is a direct connection from your goal, which is nothing but C3, and J5, there is a direct connection from, there is a direct connection from J5 to C3. This is what your goal state. Okay. What suppose if I have given 20 kilometer for this transition and 200 kilometer for this transition? What is your observation here?
Total distance.
You will
Total.
explore. See, the thing is, as per your suggestion, you will expand J5 only because this is minimal distance. Yes. From J5, if you started to expand, then there is no other choice. You can reach the goal by transiting, by traveling 200 kilometers. So 200 plus 35 in total, you can reach your goal state. The total distance would be 235 kilometer in this case. Yes or no?
Yes, madam.
Is this optimal?
No, madam.
If you are considering this path cost alone, that is utility value or performance measure value alone, path cost alone, right? It is not, which will not give you the guarantee to reach the goal in an optimal solution. First point you should aware. This is the very first point you should aware. Okay. It's not necessary that. See, it's not mandatory that you will always get the optimal solution if you are even though you are considering the path cost for expansion. There is a possibility. In real time, there is a possibility, right? But if you are selecting J4, what is your consideration? 100 plus 20? 110 plus 20? 130 only. The best possible route is C1, J2, J4, C3. Yes?
Yes, madam.
How do you solve this issue? That is why we need a heuristic value. Got it?
Yeah, yes, madam.
I'll tell you. Yeah, I'll tell you the importance of heuristic as well as
path cost.
path cost. The difference between heuristic and path cost. Okay. I'll take the same example. Yeah. So as of now, I have considered only path cost to take a decision. If you have multiple choices, if you have multiple states, right? How good one particular state is can be assessed or can be evaluated based on the path cost or utility value. That is fine. Okay, I can proceed. There is a possibility. Fortunately, you can reach the goal state in an optimal solution, but it's not guaranteed solution. Okay. So that is why we introduced another terminology which is called as heuristic value H of n. Path cost is nothing but this is which will tell you the distance between this transition alone. Yes, path cost from C1 to J1, C1 to J2, C1 to J3, right? It's a non-goal state, but the heuristic will deal with goal state, or it's a goal-oriented approach. What is goal state or goal-oriented approach? How many states are there? By seeing the transition diagram, let me know how many states are there. How many nodes?
7 states.
7. C1, J1, J2, J3, J4, J5, and finally you will be having the goal state which is called as C3, right? Heuristic values are nothing but which will tell you from C1 Okay, from C1, how much direct distance? From C1, how much direct distance calculation, Euclidean line distance calculation, right? How much distance it will take? Or from J1, how much distance it will take? J2, how much distance it will take? J3 to C3, J4 to C3, J5 to C3. It's a goal-oriented approach. From each and every non-goal state, if you are considering the performance measure as distance, how much distance it will take to reach your goal from all non-goal state, right? Just assume from C1, uh, uh, it's like 130. Yes, from C1, the distance is 130. And the J1, from J1, it will take 150. From J2, it will take, for example, 130 or 120. From J3, it will take 200. J4 also, it will take 120. From J5, it will take 200. Yes. C3 to C3, it should be 0.
0.
Yes. Okay. How do I know these values? The previous pathcast is very, very simple. It's a distance, actual value. Yes. Pathcast is actual distance. What about this heuristic? Heuristic value can be extracted from the domain expert. This particular value can be extracted from the domain expert. For this scenario, that domain expert can be like a cab driver, right? You'll ask a cab driver or auto driver, right? From here, how much time it will take to reach the Chennai airport or this particular location, or right? Likewise, you will ask. So one cab driver or one auto driver will give you, okay, it will take 30 minutes of time, right? Another cab driver will tell you, okay, it's a peak period. Obviously, it will take 45 minutes to 50 minutes. So accordingly, you will plan. Yes or no? Such informations are called as heuristic value or estimated value. These values are estimated by domain experts.
Domain experts.
But there is a possibility, even though you can ask information from cab driver, what suppose if the cab driver is new to the location, right? Very less past previous historical experience, then they will directly tell that, okay, it will take, okay, now it will take only 30 minutes time. From here to airport, it will take only 30 minutes. If you plan accordingly, see, what suppose if it is a peak period, the experienced cab driver can give you, no, it will take 50 to 1 hour to reach the airport because it's a peak time or traffic will be there, right? So if they have given that kind of information, then obviously you will start early. If you get this information, you will start early, so you won't be late for the airport. And if you consider this, then your resultant state will be not that much promising. Yes or no? There is a possibility, even though you are getting the information from the domain expert, there could be a biased value. We should analyze whether those values are biased or promising value using some properties or using some mathematical approach. Okay, is this clear?
Yes, ma'am.
Yes, ma'am.
So I hope now you understood the difference between heuristic value and the pathcast, right?
Yes, ma'am.
Yes, ma'am.
Right. If you want, you can take 5 minutes of break. What's the time? Yeah. Just take 5 minutes of break.
Yeah, sure,
Yeah.
madam.
Okay, shall I proceed?
Yeah, yes, madam.
Yeah. Yes. So this is about your first scenario, right? And as per our first scenario, we don't have, I mean, nothing is available in the knowledge base of the agent. I mean, in the memory is empty, right? So the agent will start explore the scenario or location, and each and every transition needs to be recorded or needs to be stored into the knowledge base as a fact for future reference or future inferencing, right? So the thing is, see here, even though you have multiple choices, the agent will take a decision, the best optimal solution based on some utility value. So based on some numerical value, right? There the reasoning comes into the picture, right? Okay, this route takes only 50 kilometers compared to other routes. This is the shortest route. That conclusion, that reasoning part comes into the picture, right? That is what your first module, not first module, as per your flow, as per our flow. Module 1 is Introduction to AI, a completely theory. Kindly bear with me for the first two context session, right? Complete theory. We will introduce the formal definitions of AI, applications of AI, and the different perspectives of AI, evolution of AI, right? And then in the module 2, we will move on to the problem solving agent using searching, right? So just now we performed one transition, right? Yes. So if you know for sure about initial state and all possible actions, for example, action 1, action 2, action 3, you can generate the successor function or transition function. Yes or no?
Yes, ma'am.
Yeah. So
Yes,
this
madam.
is like S1 or S2 or S3, right? Using these states, okay. What suppose based on some path cost or utility value, if S2 is best, if S2 is good enough compared to S1 and S3, then you will start exploring from here S2 to all possible actions A1 and A2. Then this will be S4 and S5. From here, what suppose if S5 is the best, then you will select. See, this is how you will explore, right? Right? The exploration is nothing but you are trying to search the goal. What is your goal? Your initial state is 8 and goal state is 7. Can you get my point? We are trying to convert our real world problem statement into a AI related problem by adapting initial state, possible action and successor function so that you can start generating the successor function or states, all possible states. Out of all possible state, it's very simple to reach the solution. You can search, you can start searching the solution once you have generated all the successes. Yes?
Yes, madam.
Yeah. So that is where we need a module to how we are going to search. How, I mean, with by using different searching strategy, we can reach the solution, right? We can start search the solution. So either you can start searching by like this level wise search or depth wise search like this depth wise search. So based on the approach adapted, the searching algorithm will differ. That is what our discussion in your module 2, right? And moving on to the module 4, what is this knowledge representation using logics? What is this? What is knowledge representation, first of all?
Knowledge base that we are
Converting.
building
Yeah,
after
we
this
have
protection.
knowledge base, right? In each and every transition from junction 1, if you take move right, then you will end up with dead end. This is what knowledge, right? Yes. How do you represent this? How do you represent? Just like that, shall we represent like this? J comma MR is equal to dead end? No way. We should have some encoding or we should have some proper approach to represent our knowledge, right? So that is what that is where we need a module 4, which is nothing but knowledge representation. Whatever we have learned during the exploration phase, that should be effectively stored, and that, see, if it is not effectively stored by you by adapting any of the technique, then we cannot infer, right? So that is why we need a logical representation. Using logic design, we are going to efficiently store such learned information into the knowledge base, right? That will be discussed in your module 4. Is this clear? Yes.
Yes, ma'am.
Yeah.
Mm.
Moving on to the module 5. What is this module 5? Same knowledge representation, but using a probabilistic way. Why we need a probabilistic way? See, I'll take this is what the second scenario, right? As per the second scenario, just assume you have explored all such informations and you have a sufficient amount of information in your knowledge base. From here to here, if I take this action, this would be the resultant state. From here to here, if I take this action, this would be the dead end, and this would be the solution. Likewise, you will be having some insufficient information in your knowledge base, right? Due to in real life scenario, due to road construction or due to metro rail construction or road block or political rally or whatever, it could be anything, right? Due to some uncertain event, there is a possibility of unavailability of this particular route, especially 2 to 3. Yes, will you agree this?
Yes.
Yeah.
We know
Yes,
that we have two possible routes, like 8 to 1, 1 to 2, 2 to 3, 3 to 7, and 8 to 1, 1 to 2, 2 to 4, 4 to 3, 3 to 7. We know that during exploration, the agent observed these two possible routes, and hence it is considered as a fact, and this fact is going to be stored into the knowledge base for future reference. Because of this uncertainty, right? Whatever we have learned so far is going to be falsified. Yes or no? Because of this
Yes,
road
ma'am.
construction, this route is not at all available at this moment. Yes, path 1 is not available. My question here is, do we need to remove the entire P1 information or that fact from the knowledge base? Or
No.
No.
can we retain
No.
such
Not
information?
not required. That is temporary.
Okay. Okay. So as per your understanding, we should keep both P1 and P2 in the knowledge base. What suppose if I have retained this path 1, right? We know that path 1 is the shortest route. Just assume it's a 15 kilometer. It will take only 15 kilometer. This is 25 kilometer, right? Always the rider or always the cab driver or the agent will select P1 only. After starting from 2, again it comes to the agent will come to know about, okay, this route is not available, we have to backtrack, and then it will go like this. Always your penalty will be increased, right? In such case. Now answer me, do we need to retain or do we need to delete? Or do we have any other choice?
We can update some flags so that until it is unflagged, it will choose only P2.
Yes. Like
Sorry?
adding as a fact.
Flag.
Temporarily we
Flag.
don't pick P1.
Okay. Whenever
Adding as a fact.
randomness or whenever uncertainty comes into the picture, we can simply adapt the mathematical concept called probabilistic model. Yes? That is, we don't need to remove or delete the entire data because during exploration only it has been observed, right? So we don't need to delete the entire thing because this event or road construction or even the metro rail construction, it takes only 2.5 years or 3 years maximum. So this is going to be, we can retain this information. Sorry, we can get back this information, or we can get back this route in near future. So in that case, instead of removing or deleting from the entire knowledge base, what I'm going to use for path 1, for the problematic path, you can provide less weightage or less the likelihood, the probability, right? The like 0.2%. And for path 2, now you can provide 0.8%. So based on this assigned weight or based on the assigned probability value, the agent or the cab driver can come to know that, okay, we can, this is the highly, preferable route for this location. So the agent will take P2 instead of P1. Okay. Okay. After 3 months of period, road construction is over. Now
Now we
we
have
have
to
to
change the weightage.
Again, we
update,
can
yeah,
increase
we
the
have to
weightage.
update the weightage for P1 is equal to 0.8 or 80% and P2 is equal to 0.2%. Using the probability value, we can update the weights. And now again, I have one more question. Will you consider your knowledge bases static knowledge base or dynamic knowledge base?
Dynamic.
Dynamic. In this case,
Dynamic.
dynamic. For scenario 2, my knowledge base is dynamic in nature. What about scenario 1? The scenario 1, we assumed there is no information as well as my environment is certain environment, not uncertainty. There is no certain environment. Or in that case, your knowledge base is static in nature. No changes at all. Whatever you have learned, that is going to be stored for a long time. Yes, there is no change in your knowledge base. Yes. So this is about your module 5 probabilistic representation of knowledge, right? Or reasoning. Probabilistic representation and reasoning. That is what your module 5. And the next important discussion is third scenario is, right? We know that there are some multiple sensors in the cab, right? In the cab or in the car. With the help of this sensor, the agent can observe the weather condition. The help of this sensor, the agent can observe weather condition. Weather condition means like day 1, right? Day 1 whether status of the weather is like rainy. Day 2 status is rainy. Day 3 status is rainy. Day 4 status is rainy, right? Likewise, you have some information or input information or perception. Now my question is, I have two questions. The first question is it possible to predict the weather condition for day 5?
Yes.
Yes, ma'am.
Yes.
Based on
Yes.
the forum.
Perfect. Your answer is yes. The second question says, is it possible to predict the road condition based on this weather condition?
Yes, madam. Based on the in 4 days. Yeah.
Yeah. Yes.
We
For
can.
this also the answer is yes. Why? Because, right, we know that if there are 4 consecutive days, like see, if there is a rainy, if there is a continuous rain in 4 consecutive days, obviously the road condition will be collapsed, right? It's not good. Yes, road condition can be in good condition or in bad condition, right? Even though with the help of the past previous historical data, the sensed data, I can assess the road condition. I'm not just trying to predict the next day weather condition or next week weather condition. I can also predict the road condition. Here, I would like to introduce 2 more terminology. One is observed event and another one is unobserved event. What is observed and what is unobserved here in this scenario? What do you know?
Weather is observed.
Yes, weather condition is observed event. We don't know about
Road condition.
road condition, but we are trying to predict the road condition, right? So the unobserved event, that this is called as hidden state. This is called as hidden state. In order to achieve or in order to get the solution for this kind of problem statement, we are going to use hidden Markov model. Yes, here that is what our 6th module. I hope now you are able to get all the modules, introduction about all modules, reasoning over time. Whenever you have a whenever you have an input in sequential in nature, like day 1, day 2, day 3, visit 1, visit 2, doctor visits, like they visit 1, visit 2, visit 3, right? So all such input informations are comes under temporal in nature, right? Whenever you have an input in, whenever your input is associated with temporal in nature and that too sequential in nature, then you are supposed to adapt this technique, which is called as HMM, Hidden Markov Model. Is this clear? Module 1 is theory, module 2 is searching problem, module 4 is knowledge representation using logic. What suppose if your environment is uncertain environment, how do you proceed? For that, we need a probabilistic representation. And module 6 is like reasoning over time. If the temporal is involved, time is involved, time series or sequential input information is involved in your scenario, you are supposed to use M6. And module 7 is, again, it's a theory, ethics in AI, right? And what about this module? Whatever we have discussed so far, we consider only one agent in the scenario. Yes? Our assumption is from module 1 to module 7, right? Except module 3, our assumption is in all situations, we will be having only one agent in the environment. But there is a possibility in real time, if you have more than one agent in the scenario, such kind of problems are called as multi-agent problem statement. Yes? If you have more than one agent, which are called as multi-agent problem statement, there are two types, right? If the agent objective is same, if you have more than one agent, like for example, 2 or 3 agents, all 3 agents objective is same, then it is cooperative agent. Can you give me one example, real-time example for cooperative agent? Cooperative agent. Rescue agent. Cooperative or competitive?
Cooperative. All agents to work for the
Yeah.
same.
Yeah, objective is same. Rescue agent is cooperative. And food delivery?
Competitive, madam.
Within same Zomato or Swiggy?
Cooperative, madam, if it is same.
Yeah. Okay, what suppose if the objective is different? I have red team agent as well as blue team agent, right? The red team wants to win the game as well as, what about this?
Win the game.
In the game.
No, the blue team, see that the thing is, the red team will try to improve the winning chance. Blue team will try to reduce the winning chance of red team. It's a strategy, right?
Sorry, madam, can you please come again? Last point, last word.
Sorry?
Last word, can you repeat once, madam?
No, yeah. Your voice is not clear.
Last
La-
word, can you repeat once, madam?
Last statement, ma'am. So the objective of blue team, they
Do
want
you want me to
to
repeat?
reduce the yeah.
Do
Winning
you want me
chance
to
of the
repeat?
red team.
Yeah. Do you want me to repeat the concept here?
Oh,
Yes,
fine, madam.
ma'am.
Just
Yeah,
last-
maybe. Huh.
Okay.
Yes. See, it's very simple. If you have two players, player 1 and player 2, right? With respect to objective function for our course, with respect to objective function, if it is, if it is a gaming environment, objective should be different, not same, right? Objective should be different. How do you incorporate this? If the player 1, if the player 1 tries to maximize the winning chances of player 1, right? Then the player 2, the opposite, will try to minimize the winning chances of player 1. So here objective is maximization, here the objective is minimization with respect to player 1 winning position, right? So hence it is, the objective is different, totally different. So obviously it is comes under competitive environment. It's a competitive agent, right? So game playing comes under adversarial search or competitive environment. We will discuss about two-player game as well, two-player game in detail, as well as I'll give you the design part of three-player game as well. Okay, so that's all about the entire course overview. If you have any queries, please ask me.
I'm on quick question. I mean, we are discussing about it. Is it something related to agentic AI?
No, no. It's very fundamental, foundational course.
Okay, got it, ma'am. Thank you.
Okay. We are not going to simulate any agent here.
And
Yes.
So,
over-
are
No,
we building any kind
Ganesh,
of model?
see, it's not a theoretical subject. It's not theory. Exam perspective, you can expect the scenario-based numerical question. That is what very first two session alone, it's theory. The next third, from third session onwards, you'll be having a numerical problems.
So assignment, ma'am, what kind of how it will be? Will it be a kind of model building or?
No. Assignment is like we will assess your programming skill in order to implement the searching algorithms or whatever topics we have discussed in the live session. That should be implemented using any Python libraries. Using Python programming, you can also use some predefined libraries.
Got it. Yeah.
Yeah.
Okay.
The detailed instruction will be provided in the problem statement itself. It's an implementation part. So you should aware of Python as well as for the second assignment, most probably Prolog.
Okay, madam.
Okay. Any other queries?
Overview
Shall
is
I?
clear.
Sorry?
Madam. Go ahead when you were telling something.
Reference book, which reference should
Yeah,
reference book should be
Textbook.
from?
Yeah, textbook is sorry. Yeah, it's in the slide itself. I forget to share. Yeah. Artificial Intelligence, a Modern Approach, third edition.
Okay, madam.
Okay. And the annotated slide will be uploaded in the Teams portal, Teams folder. I'll create one separate class material folder, and there you can get the annotated slides, right? The common slide will be available in the Taxila. Give me 1 day, 1 or 2 days time. I'll upload the first 8 contact session PPT in the Taxila portal. Okay.
Sure, madam. Actually, one small thing related to the uploading in Taxila. So
Okay.
in last semester for the open book exam, we were given instruction that either textbook or watermarked PPT provided by faculty is allowed, madam. So the one which you are going to upload in Taxila, will it be a watermarked one, ma'am, or normal one for now?
No. As of now, I'll upload only the normal PPT. At the end, I'll consolidate because our portion is like for EC2, we'll be having first 8 contact session, right? Even I'm not going to consider a single mark for EC2 portion for EC3.
Okay, madam. Okay, completely. First half
yeah,
EC2, second half EC3.
Yeah, second half only. So you can take from contact session 9 to 16, you can take the printout. Anyway, I'll upload the watermark PPT from contact session 1 to 16 only, but you can take printout from contact
9 to
session 9 to 16.
Okay, that's great. Thank you, madam. And
Yeah.
one more thing, madam, thought to check. Can we have a WhatsApp group, madam, so that if any queries are there, we can post there?
WhatsApp group.
Yeah.
Do you want my number?
Yeah, yes, madam. Either way is fine, madam. If you told in starting of the class, right, ma'am, we can create a discussion one. In case if you're fine with going with WhatsApp group as well, we'll create a WhatsApp group, madam.
Okay, I need to check with the team. I can share or not. Okay, let me check and I'll let you know by next week. Okay.
Yeah, sure, madam. Thank you.
No problems. I'll be available in MS Teams chat, as well as you can also send me a mail or in the discussion forum.
Oh, fine, madam. That's great. Yeah.
Okay, shall I proceed?
Yeah, yes, ma'am. That's
Yeah.
it. Questions for now. Yeah.
Thank you. So the next discussion is like about, so this is a real world scenario, right? Now I'm like trying to convert this into a AI related problem statement. How do you convert the problem into AI related problem? First thing, we should convert this input into a graphical representation, right? So likewise, 8 to 1 connection. From 1, there are two connectivity, 2 edge connections, 2 to 1, 1 to 5, and 2 to 3, 3 to 7. Likewise, you should come up with one graphical representation, and each and every connection can be, how do I know? See, here only one choice, right? One choice. We don't have any other choices, or we don't have any other option to proceed. So obviously from 8, the agent should take a transit from 8 to 1 only. But from 1 to 2, for you, from 1,
Searching.
no. From 8, how many possible action the agent can perform?
Only one.
Only one.
What is your
One.
initial state? Is 8. Only
Eight.
one action. For example, move up. Yes? Yeah. So then you will reach junction 1. From junction 1, how many possible successor the junction 1 can generate?
2.
2.
2, because 2 possible actions. One is move this left direction and move up direction. Yes. If for move left direction, the resultant state is J2, and for move up direction, resultant state is 5. Okay. What is path cost? In general, the path cost is for each and every transition, there must be a cost. There must be a cost associated with each and every transition. So you can also use uniform path cost for each and every transition. You can consider +5 generally, or you can also take help from performance measure to assess accurately, like a distance or anything, right? Distance or time or cost, right? Just assume, for example, if this is 5, right? And the distance between J1 to J2, 2, and here 5, right? Out of this, what is your objective function here? Minimization or maximization?
Minimization. As it's
Minimization.
Yes,
distance.
of course, minimization. Then the J2 will expand further. Yes, from J2, how many possibilities?
Two
J3
possibilities.
and
Possibilities.
J3 and J4, right? J3 and J4. The cumulative path cost is up to this. Here you will be
7.
having 7,
7.
and this is 10, right? And what suppose from here to here, 3, distance is 3 kilometer. Yes. From here, either you can go 7 or 4. From here, you can go to 6 or 3. Yes. From here, okay, you have reached the destination here. From here, you can go 5 or 6. These all are the possibilities, right? 7 and 7, right? From 8, how many possible routes are there? 1, 2, 3, 4. This is one particular path. 1, 2,
J3, 4,
6.
4, 3,
Likewise, yeah, there are multiple possibilities are there, right? From this search tree, this is technically called as search tree generation. Search tree generation or state transition. This is transition only, right? State transition diagram. Okay, fine. So, are you aware of this tic-tac-toe problem?
No,
Tic-tac-toe.
Madam, but
No, there
not
will be
good.
two player 1. See, it's very simple. Just assume your initial board configuration is empty. 3x3 board configuration, and that too it's empty. Okay. The player 1 can hold the coin called X, and player 2 can hold the coin called O. Yes. So both the players should place their coin in such a way that the coin is either if the coins are placed in a same row or in a same column or in this diagonal position, all three coins are placed in the same row or same column in the diagonal position, then we can declare that player wins the game. Yes. What suppose if I ask the player 1 to start the game, how many possible successors the player can generate?
9, madam.
Perfect, because you have 9 empty cells. So
Cells.
starting from 1, state 1 to state 9. Yes, for example, I'll consider only state 1. So assume the player placed the coin X here. Okay, the next turn goes to
Second player.
second player. So from here, the player 2 needs to place O coin. Okay, so
Yeah.
again, here we will be having 8 possibilities, right? So S10 to S18. So what is your S10? Either it could be XO. The next turn goes to
Player 1.
player X, player 1. So player can place X here, just assume, right? And the next turn goes to player 2, right? Whether the player 2 will place here or here.
The first
In
line.
The third row, madam.
Column
This
at the
one.
end.
Why?
Otherwise, player 1 will win.
Otherwise, the
game
player
over.
1 will win the game, right? Are you able to connect the dot now? Player 1 will always try to maximize the winning chance. The opponent player 2 will try to minimize the winning chance of player 1.
Player 1.
Yeah,
Okay,
now
so
it's clear.
Yeah, now it's clear, right? Yes.
Yes,
So instead of suppose if player 2 wants to maximize the winning chance, then the player 2 will place O coin here, because these all are the possibilities, right? The next turn the O can be placed here, but that is what, it's a competitive environment. So one player should be the benchmark player. If that player considers the maximization objective, then obviously the opponent player should try to minimize. It's a strategy. It's a strategical move, right? The another player will try to minimize the winning chances of player. This is how. What suppose if your board configuration is empty initially, you will proceed like this, right? Yes. Now my question is, from here, how many possible winning chances are there if your configuration is 3 cross 3? With respect to player 1, player 1 can place all 3 coins here. This is one possibility. This is another possibility. Third possibility, 4, 5, 6, 7, and
7, 8.
Strong.
In
8.
total, 8 possible winning configurations are applicable for player 1. Same thing is applicable for player 2 as well. Yes? Yeah. So along with these two, there is a possibility, even though all coins are placed, what about this stage? Can we conclude player 1 wins the game? No, it's a draw.
No. Yeah.
Yes.
Draw match.
So the
Yeah.
termination condition can be, right? Either the winning configuration with respect to player 1 plus winning configuration with respect to the gameplay can be stopped if the agent reached any one of this configuration, or if the agent reached any one of this configuration or draw condition. That is what termination. Yes, is this clear? The entire thing is called as state space diagram or search tree. In this case, it's game tree, but in real time, we will call it as search space or game tree. Okay. Yes. So it's not necessary that we should always start with the empty board configuration. Here I have a partially filled board configuration, right? If I ask you to ask the player 1 to start the game, how many possibilities? 3 successor can be generated. Yes.
Yes, madam.
Yeah. So player 1 placed X here, the second X here, and the third X here. There are 3 possible configurations are available. From here to here is nothing but one transition. From here to here, one transition. Here to here, one transition. How do you represent the transition function here? if the initial state is S naught, this is S1, S2, S3. Yes, A, B, C, 1, 2, 3. From S naught, what action?
A.
A,
Placed A.
A1,
Yes,
yeah,
ma'am.
yeah. Place the coin X in A1. This is what my action, right?
Yes,
That
ma'am.
is what from scenario to scenario, action will be different. In the previous scenario, it's only move up, left, right, or diagonal, or whatever. Depends on the scenario. In this case, I'm trying to place the X coin in one particular location, empty cell, that is A1, right? Then you will end up with the resultant state called S1. This is what my transition, one transition. Another transition could be from S naught. If the player X plays the coin where it is B1, then the resultant state will be S2. Yes. For the next transition from S naught, if the player starts or adapts the action called the player X
B3.
B3, then the resultant state will be S3. Are you able to connect the transitions, how we are trying to generate the search tree or successor function for a given scenario? Is this clear?
Yeah, yes,
This
ma'am.
very first session is very, very important because from next class onwards, whenever we started the module 2, they will deal with this kind of stuffs only. Okay. What's the time?
3:40.
Yeah, we have 15 minutes. Okay, let me start the theoretical content. Yeah. So actually, just now we started, just only we started the module 1 portion, which is nothing but the theoretical part, right? Introduction about artificial intelligence, right? So let's start by understanding what is AI first, right? So simply put, we can say that artificial intelligence refers to a simulation of human intelligence. Yes? In machines, especially simulation of human intelligence in machines. So these machines are designed to think and act like a humans and performing tasks that typically require human intelligence, right? So as I already stated, the very first module alone would be the theoretical topics, right? The rest all others, even the module 7 is also theory. From module 2 to 5, everything is we are going to discuss all topics with respect to scenario based approach or numerical approach. Okay. Yes. And the thing is actually to respect and appreciate the evolution of this particular field and acknowledge few key contributions from various discoveries. Let's take some time, like 5 to 10 minutes, to highlight a few historical events. That is very, very important with respect to this AI course. Okay. So let's begin by discussing few significant historical recordings for the next 10 minutes. See, the concept of AI or the terminology. Okay. Okay. We will discuss this slide later. The concept of AI can be tracked back to 4th century. Nowadays, we are always using the terminologies called artificial intelligence, machine learning, deep learning, neural network, artificial neural network, neurons, and all right. Yes, in the 4th century BC itself, the concept of AI was introduced, right? The father of logic. Who is father of logic? The famous philosopher Aristotle. Yes, actually, he introduced the process of logical inferences. In module 4, we have one logic system, right? Logical inferencing. Yes, according to our syllabus, yeah, the fundamental concept is derived from here only. Yes, so the Aristotle, he introduced the process of logical inferences, which involves deriving new fact from the existing information. I will give you one classic example here. I hope you're all aware of these two statements. Statement 1 says, right? Socrates is human. Okay. Statement 2 says all humans are mortal. Yes. From these two statements, what we can derive?
Socrates is mortal.
Yeah.
It's very, yeah. These two are existing information from my knowledge base. I can get it, right? From these, we can logically infer a new statement called Socrates is mortal. This is called as logical inferencing, right? Which was introduced by Aristotle during 4th century BC itself, right? So I even the association rule also, I hope you all aware, right? A implies B. If this condition is true, if B implies C is true, then
A implies C.
A implies C is true, right? So this foundational logic is crucial for AI development because based on some logical reasoning only we will proceed, okay? And the next thing is around the 16th century, right? The notable mathematician like Thomas Bayes theorem. Are you aware of Bayes theorem? And Bernoulli distribution and all? Yes. Bayes and Bernoulli introduced, both mathematicians introduced the methods to handle uncertainty that is called as probabilistic. Logic is fine, okay. See, this logic is fine, but how the logic will work in the absence of certain data? If everything is available, then only we can do some logical inferencing. Yes. If something is missing in the absence of one particular informations, right? In the absence of certain data, that is in the presence of uncertainties, how the logic will infer? Is it possible to infer everything? No, right? Yeah, here the concept of probability and the degree of uncertainty came into the picture. So they developed the probabilistic technique to answer questions about the likelihood of how good or how likely this particular event event can occur when the data is incomplete. Yes. So I hope you all aware the probability of statement 1 is true, right? The probability of statement 1 is going to be true is 0.2. Then what is the probability of same statement going to be false?
0.8.
1 minus probability of yes, which is nothing but 0.8, right? So these approaches allows for reasoning under uncertainty. This is another key aspect of AI. Are you able to connect with our modules now?
Yes, madam.
Yeah, in 1940s and 1950s, a further significant progress was made by John McCulloch as well as Walter Pitts, right? They proposed a model of artificial neurons. Nowadays, we have studied a deep neural network, deep reinforcement learning and all, right? 1940 itself, they have created, right? They have created, artificial neurons that mimicked the functioning of the human brain, right? Actually, this model used a simple binary value, 0 or 1 signals to represent the neural activity, right? If it is 0, it will disable the activity. If it is 1, it will trigger the action, right? So this is another third important critical component of modern AI, right? And 1940 neurons. And during 1950, the Alan Turing, I hope you all remember the name Alan Turing. No?
Yes, ma'am.
Yes, madam.
Is a father of?
Turing machine.
Sorry?
Turing machine.
Turing
Analytical
machine.
engine.
Perfect. Turing
Analytic.
machine. In your UG, like in BE, I hope you might have studied the theory of computation, compiler design, formal
Yes, madam.
automata theory, right?
That,
Very tough
yeah.
subject.
Correct, madam.
Correct, no? Very tough
Yes,
subject.
tough subjects.
Yeah, in the 5th unit, they have introduced Turing machine concept, right?
Correct, madam.
Yeah, all
At least
such
names are
topics.
remembered, not able to
Yeah.
remember the context.
Don't worry. We are not going to touch those topics here.
Oh,
Right?
cool, madam.
I just wanted to inform that the thing is the evaluation. See, if you have invented something new, there should be there must be some team to evaluate whether how good that particular product is, right? You can claim that, okay, I have designed this mission. This mission is intelligent agent. How do I know whether it is intelligently react or whether it is intelligently response the question, give the response to the question or not, right? For that purpose, we should have some evaluation criteria, right? Yes. So
Correct,
the
madam. Yeah.
Alan Turing proposed the famous Turing test. Turing test as a measure of machine's ability to exhibit intelligent behavior. Okay. So the thing is, see, this landmark concept laid the foundation for the field of AI and inspired generations of researchers to pursue the dream of creating a truly intelligent machine. Actually, when I started to teach this ACI course, right, long back, I just informed the students that none of the AI mission satisfied or passed this Turing test, right? Even you have a ChatGPT, right?
Yes, madam.
Yeah, please go and explore whether ChatGPT, in ChatGPT itself, you can ask the prompt, send a prompt, whether ChatGPT, passed Turing test or not. Can anyone check and let me know?
Yeah, sure, madam. We'll check.
Looks like it has passed recently, GPT-4.
Sorry?
It says GPT-4 has passed.
Yeah, GPT-4. GPT-4 passed, but the accuracy is like
73%.
whether they have given any quantification.
But this is not in all situations. That's what.
Not yeah, that is
Yeah.
what. That is what. See, it's a very complex system, very complex evaluation system, right? So even not 100%. This is very important, right? Not even 90%. You can check.
Yes, ma'am.
Not even
Yeah.
90%. You can check. Now, we don't need 100% result. Not even 90% result. They have improved from 30 to 40, 40 to 50. Likewise, only they have improved. Okay. So the 1950 itself, the Alan Turing proposed this famous test called Turing test. There are two types of test. One is complete Turing, that we will discuss in the next class. Don't worry. Already we have only 5 minutes. Okay. So actually the term artificial intelligence, right, was officially announced or officially coined by John McCarthy in 1955. See the year 1955
55.
itself, and it became widely known following the Dartmouth Summer Research Project Conference. Okay, so this conference is considered the starting point of AI as a field of study. Okay, because they have proposed lot of research paper. They have published lots and lots of research paper with respect to AI. And I just wanted to check these 3 lines, read these 3 lines and tell me what is your observation. What you have observed here. An attempt will be made. This is one of the research article, right? One of the research article, I have taken the paragraph alone. I have taken the snapshot of the paragraph alone. Published in this conference, 1955. An attempt will be made to find how to make machines use languages.
So something like something like it looks like how like today ChatGPTs are like that. There will be coming in future. They have censored. They have censored mentioned that.
Yeah, correct. Could you please tell me the domain name?
Machine learning.
Machine learning is perfect. Natural language processing. See, 1955 itself, they have researched this. They have started to research. Yes?
Yes, madam.
Yes, that is why I just wanted to give you the evolution of artificial intelligence, right? We will discuss these two projects in the next session, right? But the brief history is 1950 itself, they have started the AI, right? And 1960s, they have introduced a specific programming language. Here, 1950 itself, they have introduced the Lisp programming language for AI, as well as in 1960 to 70, they have introduced another programming language which is called as Prolog for logical inferencing, and to take care of logical reasoning and inferencing, they have introduced the Prolog. Still, we are using one of the assignment is second assignment is based on Prolog only. Okay, and from 70 to 80, this particular period is called as winter, AI winter period. Why? Any guesses? Even though they have
No,
that much content or that much knowledge, and even though they have the math behind each and every model and approach, right? This particular 10 years.
Progress was not made, madam.
No.
processing
Even
capability.
see, they have received fund from the government as well as the the private sector, right? Still,
Systems are
not
not
able-
capable enough.
yes,
Yeah.
that is the main lack, right? That is the main important point and concern here. Infrastructure, as well as if we want to deal with the deep learning, the first requirement itself, large data. Yes,
Yes, madam.
even though we don't have large data that time, even though you can somehow we are able to collect it, we cannot, we don't have that much capability to accommodate such large data, right? So because of the infrastructure and the usage of internet is very, very less that particular time. Yes. So that is why this particular period is called as AI winter. But after 1980, the graph is only upward till today. Yes.
Yes, madam. It's evolving much faster now.
Yes, that is why even in 2026, we started to, you all have joined the AML course.
Yes, madam.
Yeah. So see, actually, this course is very, very interesting course. Don't worry. Don't worry about the mathematical part. I'll explain the each and every step of each and every algorithm in a clear manner so that you will get, even I can connect the dots from, like, I can connect the situation from real world scenario to your problem statement so that you can easily understand, you can easily connect. Okay.
It is interesting, ma'am, like the way we told by using the generalized example, traveling salesman problem, and starting with the tech words. That was nice, and we were able to connect the dots.
Yes. That is why I don't want to start with this theoretical part. Always I started with the sample problem statement, the toys problem, traveler's problem, so that you will always, you will know all the terminologies, right? You will aware of all the terminologies, right? So in the upcoming modules, it will be easy for you to understand. Okay.
Yes, madam.
Any queries?
As of now, that's it, madam.
As of now,
Maybe
no?
the silence
Okay.
can be taken as no queries for today.
Okay. Thank you. Then shall we wind up? Yes.
Yes, ma'am.
Thank you all.
Yes, madam. Thank
Yeah,
you, madam.
recording
ma'am.
will be
Nice meeting
available
you.
after 10 minutes. Yeah, thank you. And I'll upload the annotated PPT in the Teams immediately. Okay.
Great, madam.
Sure,
Thank
ma'am.
you.
Thank you. Have a
Thank you.
good day, ma'am.
Good
Yeah,
day.
Happy
thank you all.
Saturday, madam, and team.
Yeah, thank you.